So we finished the discussion for SDN, and finally, we ask you to think about the future of SDN and the future network protocols. Therefore, we have this question. So this is a discussion in class 1. And later, within the second class, the current class, we will have ICMP, and we will have Simple Network Management Protocol, SNMP. Before that one, we already have the attendance check-in for today. And let me check. Okay. Others fail to have that one. So this one. Likewise, 2 minutes for you. All right, so let me move on to the next one. So let me reopen that one. Something wrong? All right, so let us continue to talk about ICMP. So ICMP is the control messaging protocol. All right, and actually will be used by host and router to communicate network layer information, specifically error reporting, echoes, and ICMP because IP, so above IP, so network layer protocol, and it is above IP. And ICMP because of above IP, so it will be carried in the IP datagrams. Well, for ICMP messaging, we have the fields called type code. All right, and some description. Here we have a type from these. Maybe you are curious why this value. Yes, I don't have any idea why we have the setting for the value for type and code. But yes, we have that definition so that we have some of the ICMP messaging. And later we will have some specifically, let me point out type 3 and code 3. So destination port unreachable because later we will use that one. And type 1 and 1 and code 0, TTL expired. And maybe the others, but later we will use some of those. So that's why I point out the two types of messages. Well, so ICMP can provide you the error reporting and something else, but we want to use the current example to let you know, yes, we can use the trace route along with ICMP messages. Well, trace route in chapter 1, we don't know, we will send probing messages. So source sent three UDP segments to the destination. The first one send TTL. It's 1. Second TTL 2. So we have 1, 2. So somewhat like we have the repos. A repo can reach the destination, but different from repos, once we reach the first one, we will have the feedback messaging because of TTL 1, 2, 3, and the others. And datagram in the nth set arrive at the nth router because of a TTL. And here we try to let you know, yes, we use the ICMP messaging. You see, send source ICMP message 1 and 1 and 0 because of TTL expired, right? All right, so reach it, but expired. So we'll send ICMP message using type 1 and 1 and the code 0. Of course, ICMP can include the others. All right, because we want to provide a trace route. So to have the function of a trace route, it says, oh, okay, you can include name of the router IP address. So trace route can include the information. Well, after now, maybe it says 1, 2, 3, 4. Finally, we'll reach the destination. All right, we'll reach the destination. Of course, we will have the ICMP to recall RTT, and so that we have the time. And of course, we have a set bar 3. Well, so after now, we don't know, we have the probing messages. For probing messaging, first one, we have first set, we have TTL 1, second set 2, and the other. But for each set, we have 3 probing messages. And for the intermediate one, we will have the ICMP message 1 and 1 because of TTL expired. And for the stopping criteria, because we cannot do this eventually. So once we reach the destination, of course, trace route set the destination. How about once we reach the destination, destination will send one ICMP message, but use this one, pole unreachable. Maybe you think, okay, pole unreachable. Pole unreachable, because we want to stop it. It reached the destination port, but it cannot reach the other destination port anymore. So we choose this one. Or maybe you think, if we want to stop it, which one you think it should be the best one? You can re-examine, but we select this one, type 3 and code 3 to send it back from the destination. Even for the destination, it's reachable, but we use that one because we want to stop it. So we should have a reason. Somewhat like the reason to reject. So to reject, so we choose this one. 3 and 3 and port unreachable. In fact, port reached by this one. Or maybe, the other reason, but you think, okay, we want to have a reject message so that we can stop sending the other. So we have this. And so that this one can send it back to source, and source will stop. All right, so in fact, ICMP can provide the function including error reporting, but we use it for the working mechanism of trace route, including the TTL expire, including to stop sending messages further using port unreachable. All right, so this is ICMP. We already have a really short description above IP, and that you have the necessary function. Well, it's ICMP. We just already have a really brief discussion for ICMP. Well, that's it, ICMP. And next one, we start the description for network management and configuration. Actually, it's an SNMP and network configuration with the so-called language, we call language. Well, we have a YARN language for network config. Well, network management. We have the autonomous system. Here it's network. It doesn't mean the management should be a network, but here management we can focus on autonomous system so that we can have the management. But if we focus on network, then we have the network management, including hardware, software components. And of course, only network? No. Jet, airplane, we need to have the proper management. Nuclear, power plant, we need to have the management, and the others. Those management maybe not similar to the current network management, but with the similar concept. So that's why we want to mention the other complex systems still need to have monitoring, configuration, control. Well, so the other systems still need to have monitoring, configuration, control. So that's why we need to have SMP for sure because of the management for the network. And of course, we need to have the configuration. Because of configuration, therefore we have the specific one, network config. Well, you can check this one, network management, saying these, including deployment, integration, coordination of the others. All right, so just for your reference. And management, of course, we will have two roles, manager and manage entity. So managing server or the controller, and the other one be managed, right? So manage entity. And here we have a data or status. We want to get some status of the devices, and so that we can pass on the data to have the necessary control. So this is a goal for the network management. And this is a simple description. We're also managing server, manage device, and the data. So we can have the general concept to have the network management. Well, of course, we want to have the protocol, network management protocol. Later, we will already have SNMP. And based on the protocol, of course, is a communication. The communication provides to have the data query, configuration setting, and the others. So we can pass on this to have the setting for the device. Of course, the device will be monitored by the server. And first of all, you can have the simple one, CLI, command line interface, the simple one. So you can something like key in the command and get one. So command line interface, something like if you want to have the setting for HTTP, that's a possible version of a CLI. Of course, CLI, it takes time. And also you need to know all the details. Therefore, not suitable for the real situation. Instead, we have a protocol called Simple Network Management Protocol, SNMP. So SNMP, and SNMP, then we have the data. We will have the MIP. Actually, MIP is the data. So we will have the operator query and set device data. And device data for SNMP we call MIP. MIP actually is 3 terms you can check. 3 words, and so that we have these. All right, this one, MIP. And we have a management protocol. If we want to have the configuration, we can have a network config with the language called YAM. And it's the abstract network-wide. And we will have the emphasis on the configuration. And we have the language, modeling language. All right, so in fact, we can have the specific one, network config. Well, CLI, actually, you should know all the functions. So you need to key in by yourself. So that's the CLI, and we skip it. And of course, you can check if we have all this, and then you can pass on CLI to implement, but you don't like that one. And the SNMP will have a 2 ways to convey the data. Data we call a MIP. A MIP info, and so that we have the following 2 ways. From server, from the managed entity. So similar to the other protocol, we have a request and response. All right, based on the mode, request and response, of course, then we will set those. And this is a first way. We will allow the manager or the server to send requests, and so that we will get a response from the managed entity. And another one, it's a repo, so we have the trap message. And just one way, I want to have a repo sent to you, so this is the second way. And of course, for SNMP, similar to the other protocol, we will have some message type. Well, we have a message type including get a request. We can have a get. We can have a get next one, get a bug. All right, and we can have set, request, response, and trap. Trap previously, you know, it's the message from the managed device to the manager. So agent to the manager. So inform manager of exceptional event. So this one is easy. Response, yes, I want to reply. And set request. Set the meet value. And get, just want to get one. Then we have the data. As for how many, just want to get the next one and get a bulk. And so that we have a lot of messages. So we can have those. And yes, for the protocol, sure, we can have the format. Here, we already have the format. We have the corresponding one. Because of a request, so we already have the request ID. And here, this is the trap message sending back. So this is the something like the feedback message. So we can base on this. I think if you are interested in all the details, you can check the format. And of course, because we want to make it viable, so we have the format definition. And MIP here, message information base, it's MIP. All right, so we have the data structure for MIP. You see, we will have a MIP module, and you can check RC for the details of MIP. How we have those. And for network config, we will have associate language. Here we have the so-called language, data definition language. You see, for network management, data structure is important. So we have a structure of management information and SMI. Someone like, okay, we have now of the information, but it provides you the data definition language. So we can use SMI to have the someone like to define the MIP. And possible one, we can define something like, oh, we have objective ID, name, type, a comment, and so that we can have something like it's the data set. All right, how to have the data, and we can use SMI to have the possible definition, data definition, including anything you want to have. All right, so then I have the briefing to SNMP. So SNMP actually it's the detailed version, and for SNMP the important one should be how you define the data information code MIP, and how to define that one. We can use the allowable language SMI, and SMI allow you to have your own definition. If you want to try it, you can try it. So this is the first part, SNMP. And the second part, we already have the configuration. Likewise, yes, we have the overview simply. Yeah, the current one, we want to have the configuration. Managing actually is the previous one, and right now we want to have the configuration. So yeah, we have this, and so that we can have the configuration. And configuration, we have RPC, and we have the setting network config using XML. All right, and we will exchange the message over the secure, reliable transport, so TTL protocol. So we can have this. And configuration, of course, we should have a few rounds to have the configuration setting. And yes, managing server and agent to be configured. So we will use a network config to exchange the message. All right, and previously we have the RPC and send, and then we have these to have the setting, just the setting. All right, and close it. So without know, yes, we need to achieve the goal, and then we may have some wrong, and so that based on the wrong, then we can finish the setting configuration. Well, configuration. If you want to set configuration, we need to get the current config. We need to edit, and we need to lock, and we need to unlock. Because we have the setting, of course, we may have these. All right, and based on this, then you will have the configuration. Well, of course, they know how we have the configuration. So that's why we have this operation. And as for the operation, we have the corresponding description for the operation. So you can check them for reference. All right, if we have the previous one, network config RPC, then we have the possible example. But this one, I think, just for your reference. So we have ID. Okay, we want to change a configuration, edit, right? And here we want to change this Ethernet. So you just want to say, okay, we have the previous operation to use some operation, and these operation that yes in XML, so we can have these. And yes, if we want to have the further configuration, we have the corresponding language. Even previously, if you don't have the specific description, we will have XML to have the format. But we can provide you this. And this one, it says it's a language, the data modeling language. To specify structure, syntax, semantics of network config, network management data. Still data. All right. So previously, we have SNMP. So like SMI, we can set the built-in data types by using YAM. All right. Okay, so similar to SMI, you can have this data modeling language, and so you can have the data setting. All right, so just for your reference. And right now, we finish actually all of the discussion, but later we will have the actual description for distant vector routing algorithm. Before that one, we already have one problem for the thin pair share discussion. So let me good to have the good property. So all of you serving as good 1, no good 2, and good 3, and good 6. So we have a good 1, no good 2. And good 3, and good 6, no good 5. And take a picture for the current thin pair share. I think it's easy. Even we don't have the description for SNMP, but we don't know why we want to use UDP rather than TCP. The answer known in the previous discussion in chapter 2, right? Okay, so this is the QR code to reach the entry. And also I will already have this. So you can think about this with your neighbors. So allow you to have 5 minutes to have a discussion first. Oh, sorry. Or maybe I change it to group 5. All right. So up to now, maybe we have possible answers on Padlet. All right, we have one from Quentin, and one from Huei-Wen, and one from Guanci. And this time, check the 3 possible answers. Which one you think you like? Then you can put a like on the answer. So go and try to have it. And so that then possibly you may think which one will be the proper one. Okay, go and check the 3. Okay, and also this one as well. You just cast your like on the message you reply. So Jiawei says we may have a losses. And Huei-Wen says, okay, TCP may have the other thing to do. And the other one talking about SNMP. So maybe not SNMP. UDP simple fast and don't care about the others. But For Quentin says it's SNMP. Because of SNMP, so we choose UDP. No, we should consider the features of a UDP and TCP. All right, so it doesn't mean SNMP, so we choose it. But we have some other reason considering this. How about losses? We care about losses. So that's why I ask you to think about in chapter 2, we already have the reason. SNMP choose UDP rather than TCP. And this one, we may have a failure, right? But for the other CS, talking about the drawback of a TCP. Of course, this one maybe, I'm not sure, perhaps ask the ChatGPT to provide the answer. You see, SNMP is simple, so we should have this one. And for the simple one, we can have the simple processing. All right, so still allow you to have a chance to have, maybe we still need to proceed to the next one. So this time, I think, just for your reference, which one you like, then you can set your case. And so that you like some of them, if possible, you just use your way. Or maybe you don't like them. All right, so that's it. So this is a possible activity. And likewise, that you have the due date to 4 p.m. today, and I will upload the answer for your reference. So this is the final. This is the final TPS because we will close it soon. So summary, up to now we learned a lot. Of course, we learned a lot. We have the control plane for this chapter. And compared to the traditional one in the previous chapter. So SDN. So SDN, we will have the two versions of a controller. ODL, the light one. ONOS, maybe the complete one. And we have ICMP network management and the others. And of course, for this semester, we won't go further. So we will reach the end of chapter 5 only. And this is a review for you, and you can think about the others. So we already have this activity. In chapter 5, we're talking about this. All right, and of course, we have the discussion. Finally, we have all of these. So we further that we have this one. Distance vector. Actually, distance vector can have something like some table. Dx to some node that says this is the distance vector. So distance vector, we will have the distance vector table. Well, so we use the synchronous manner. Initially, only this network, only this network. X to anyone, X to X. X to itself, it should be 0, right? So 0, and X to, so row, the first row, X to Y. The direct one is 2, X to Z is 7. So likewise, we can have dy to the other, dz to the other. And once we have this, remember, distance vector asks us to have the message update. So we send message update to the others. So message update to the others for X, of course, care about X itself. Therefore, we receive it. Okay, compared to this one, we have the new message. So we need to recompute. And recompute, then for X to Y, recompute X to Y, so we can have CXY, Y to Y, and Z to Z to Y. And finally, we have the update is 2, right? All right, so we have the same one, it's 2. And how about to z? X, y, y to z, x, z, z to z. So that we have a 3. Yes, we have the update. And because of the update different from the previous one, so we will send the update to the neighbors. All right, likewise for the others, think about this. Okay, so this one, for y, no change if you implement the Bellman-Fold equation. And this one, yes, we have. So we will have the update from x and y. And finally, assume we have the simplest one. Then stop, no change. So this is the distance vector algorithm using the distance vector table. Even it's a smaller one, but it takes you a long time to get this done, and so that we have the information. Well, this is a way to reach the node, how we reach the node. All right, so this one for your reference. All right, this one for your reference. And yes, even for your reference, you know how to carry out the distance vector table. All right, so finally, this is the self-reflection on chapter 5. Okay, that you have for 2 minutes to finish it. Yes, we have a BGP, we have a SMP, it's correct. Distance vector, so consider distance, but you should have a vector as well. And yes, for the current one, we have the control one, so control plane. MIP for SNMP, and OSPF for the routing protocol. And dash chart. All right, so correct for all these. But yes, we have the different rule. Maybe some of you think, okay, BGP, it's really important. SNMP is really important. And MIP. MIP, we have a movie called Man in Black. Maybe you don't notice that one, but actually, oh, okay, MIP is that one. No, MIP is the management information base, MIP. Finally, the code is BGP. So maybe you know, okay, the important thing should be BGP. That's okay, no problem. Yeah, up to now, the code should be BGP. And also, you think it's really important to have SMP. All right, that's okay. All right, so this is the self-reflection on the current chapter, chapter 5. So same, let me move on to the next one. And this one, not the questionnaire by the school, it's the questionnaire by me. We may have some skill. Even we have some non-skill, I will emphasize some new skill provided by me in this semester. And we will provide this in actually this Wednesday. And this Wednesday we also that have the quiz, the final quiz 3. So let me have the closure for today's class. In second class, actually, we talk about ICMP and SNMP network config. And finally, we have the actual discussion about the distance vector to have the complete distance vector tables. Well, that's it. This is a discussion in the second class. Before you go, let me make sure any questions. If not, see you this Wednesday, and don't forget to prepare quiz number 3. Of course, I already have the reference solution for chapter 5. You can check our line group, right? All right, if no, see you. Bye-bye.